Okay, we're reviewing stats today. If there was only one thing that you understood from stats, you gotta understand what standard deviation means. Okay, first of all, what does deviate mean? It means that you're different. Okay, all of us deviate from the norm in some way. The norm would be if we just like take the average, I don't know, hair color, for example. Well, your hair isn't going to be exactly that color. Okay, so we're all different than the norm in many different ways. So let's say we take a test score and it's out of 100, and we say the average of that test comes out to 85. Well, isn't the average good enough? Well, because you could get an 85 average by having only 3 people to take the test, and they all got 85. Do you get that's totally different than like 1,000 people are taking the test and they have scores all over the place and they average an 85? So average isn't good enough. You need to know more about the data. So like, was it all really close? You know what I mean? Let's say I give you 3 people to be on your team. And on average, they have an IQ of 110. That sounds pretty good, right? But do you get, if the standard deviation is like 70, that would mean, oh my gosh, I got one incredible genius on my team and 2 people that aren't so smart. That's totally different than 3 kids that all have an 110. Okay, so that's what standard deviation for is sort of to tell you what the group is like. So let's say I have this group over here, and their average on the test is an 85, and I got this group of people over here, and their average is an 85. And this one's standard deviation is 10, and this one's standard deviation is 1. I'd like you to discuss what the benefits would be of each. If you're going to work with these people as your partners. All right, so now I got to get you in groups. I'm going to pause the video while I do that. Here's some of the things that I heard people say as I was walking around. I heard one group up at the front say there might be advantages to people that think differently than each other. Maybe the people that all are at 85, might kind of think the same way because they're all getting the same scores. Whereas if you get a diversity there, you got some people who think differently than the others. So, all right. Well, for sure, this group, if you have an 85, an 86, yeah, and an 87, do you get that would average an 85, and it would have a very small standard deviation? Do you get what I'm saying? Now, how would I know exactly what the standard deviation is? Well, actually, you would use your calculator. So would you please grab your graphing calculator and use the numbers 85, 86, and 87. Doesn't matter what order you put them in. It's irrelevant. Would you would you please find, I know the average and the standard deviation are not going to be what I said, but they are going to be similar to what I just said. So use your calculator, figure out the average and the standard deviation for that simple little list. I'm going to pause for a second while you try that. Okay. Somebody smart was able to do that average in their head and then say that's not going to be an average of 85. You're right. It's an average of what? 86. Now, here's what your calculator would have said. I'm going to pause while I pull that up. All right. So my computer, for some reason, is not allowing my emulating calculator to be up on the screen. But I'm just going to trust you guys that you put that into edit, list 1, and then you did one variable stats on it. If you didn't already do that, you should do that. And then the first thing is the average, and that came out to 86. Yeah, I think it's got an X with a little bar over it. Does that sound familiar? Okay, good. And then there's 2 kinds of standard deviation, the one with the S and the one with the that. Okay, that one, standard deviation, is the better one of the 2 because we have all the data here. And it comes out to about 0.8. Is that correct? Okay. So now, here's my question. If those 3 people had taken this test, and obviously their scores were all really close to each other, okay, then what's this person's z-score? There was a little thing you could do with this average and this standard deviation and their score to tell their z-score. I bet you there's only 2 people in the room that remember this. Give it a shot. It's a number. See if you get it right. I'll pause while you give that a try. If you have forgotten how to do it, I need to remind you what the formula is, right? How many people think that you might have a shot at this? All right, I'm going to give you another minute to give that a try. Okay, you'd have it by now if you knew what to do. And let me show you how easy it is. You take the 87 and you subtract off the average, which was 86, and then you divide by the standard deviation of 0.8. Raise your hand if you knew that. All right, a few of you remembered. A lot of you didn't. Did you see what I just did? You subtract the average, divide by the standard deviation. And it comes out to, in this case, 1 divided by 0.8, which is kind of close to 1. What was the answer? Our z value was 1.25. Let me tell you what I know that means. That means that I was, this z-score, if I was the 87, that means I was above average because it's positive. If it had been negative, you would have been below average. Okay, because you subtracted the average. Next thing, if it's positive, it's above average, negative, below average, and then the bigger the number is, the further off you were. Let me ask you this. If it had a z-score of 1, do you get, since the bottom of the number is the standard deviation, the top would have had to also have been the standard deviation? If you had a score of 1, what does that mean about your score? You had deviated the exact standard deviation. Yeah. That'd be like, in the class, let's say that we did shoe size the other day. The guy's shoe size on average was like 11, and if the standard deviation was 1, you get how you could just do this in your head if I said, this kid's got a shoe size of 12, where the average is 11. Oh, he's off by 1 standard deviation. What's his z-score going to be? 1. What if the average is 11, and the kid's got a size 10 shoe size? Negative 1. Very good. Okay. Do you get, if you are a number less than 1, then you were actually not off by the standard deviation. You were off by less than the standard deviation. All right. So let me give you one more little set of data. Let's go with hat size. You get that if you put on a hat, they oftentimes have little adjustable thingies because some people have small heads, some people have big heads. Okay. I made the mistake at the Air Force Academy buying this hat. Didn't even look at the back side to see if it was like the adjustable kind or not. It was called a flex, which is basically means that it's supposed to stretch and like fit one size fits all. Problem was, when I actually put it on, it was kind of tight, so I couldn't, like, you know, yes, it was flexing, it was like kind of stretchy, but it was like, feel like there was something squeezing the top of my head. I was like, dang. So I tried to bring it back. It was like 1 second after I bought it. Sorry, can't do returns. I'm like, okay, so I guess I have to just deal with it. All right, so head size actually affected me. Did you know that there is theories on head size that if you had a bigger head, therefore you could have a larger brain, and a larger brain would therefore mean you are smarter? How about this? How about this? Would you agree that a grasshopper doesn't have as big a brain as you? And do you agree that you're probably smarter than a grasshopper? With some exceptions? Okay. But should that automatically mean that people with bigger heads, like 2 adult humans, are smarter? All right. Some people still think it's true. All right. So we're not going to do this right now because I would have to ask you what your GPA was and how big your head was. But we could do a little correlation thing. And I imagine for a moment that right now I measured all your head sizes. I got like a little tape measure. And the average cranium size was 20 inches around with a standard deviation. That means like all the way around this way. Okay. With a standard deviation of 2 inches. Okay. So then here's my question. Do you remember that CDF thing that we just did the other day? Could you do a CDF on this? Oh, I hope so. Number 2, could you find the z-score if I told you Bob's head is 19 inches? What's his z-score? You should be able to do that. Another thing you should be able to do with this is something called an inverse. It's like CDF, It's on the same menu on the calculator as the CDF, but I'm going to show you all of those really quick. All right, first of all, z-score. Bob's got a 19-inch head. What's his z-score? Well, right away I can say it's less, so it's negative, right? And is he off by exactly the standard deviation? No. So his z-score is somewhere around negative, like less than 1, because he's not off by as much as the standard deviation. But if you needed to find out exactly what it was, use your calculator. There's a little formula. What's his z-score? Compare it with your partner. See if you guys get the same answer. What's the z-score for Bob's 19-inch head? If there was a bell curve for this, what would the peak of the bell curve be? 20. Good. If we went out one standard deviation, do you guys remember those numbers yet? We went out one standard deviation in both directions, and that standard deviation is 2, right? We'd be going up to 22-inch craniums and 18-inch craniums. And then what percentage of the people would be between there? Do you have that memorized yet? 68. Very good. Anyway, there's a couple other numbers like that that you should know. Let's go back to that z-score. You should have said 19 minus the average, which was 20, divided by the standard deviation, which was 2. And so this is 1, or negative 1. Negative 1 divided by 2 is negative 1/2. Raise your hand if you had negative 0.5. Awesome. You know how to do z-score now. And this is what's called the normal distribution, and you should have that one memorized. If you go out one standard deviation in both directions, you get 68% of the people on the inside of that. All right. Then, now let's talk about that CDF thing. Do you remember yesterday's CDF? Would you please grab your calculator and go to the menu? It's right above, so you use second to get above. It's right above the distribute menu, or no, VARS, which is D-I-S-T-R, distir. Okay, get in there. Wish I could open my calculator right now, but it doesn't seem to be wanting to work. I'm going to try one more time. All right. So one twist on the CDF kind of question is that it's an inverse. Do you remember doing this with the sub when I was gone? Inverse CDF. Is it actually called inverse CDF? No. What's it called? Inverse norm. Okay, if you're going to do an inverse normal, what that does is the opposite. Instead of saying what percentage of the group is this, it will do something different. It'll say, I want to know what 95% would be. All right, so let me give you another problem. So let's say that you study zoology, and you end up going off and get a job at a game park in Africa. And you are in charge of the rhino herd. You got a whole bunch of rhinos. One of the things that you do is you figure out by using digital pictures about how much these things weigh. You can do that kind of thing. So you take pictures of them, 3D pictures, and then you're able to go, okay, I can estimate this one weighs this much. And basically, you keep track of your herd. And you now know that your average rhino weighs 2,000 pounds. I'm making the numbers nice for you. That was the average. And the standard deviation, just to make it nice again, let's say it comes out to 50. So that means if you grab most of the rhinos, you grab a random rhino, do you get that they're going to be pretty close to 2,000? They might be 2,050, they might be 1,900 or 1,950 in weight. Okay, but here's my question. What weight would you need to pick if you wanted your top 5% biggest? No, I'm going to go smallest. That goes from 0 to 5%. Your tiniest rhinos that you have, your 5% group, the lowest 5%. Here's how that inverse would work. I know you haven't done this in a long time, so it goes like this. 0.05. Who knew to put that first? Good. That's right. And that's, the mean is coming next. pretty sure it's the mean. Okay, pretty sure it's the mean comes next. Okay, and then last is the standard deviation. And the nice thing is that those are always in that order. The average is first and then standard deviation. Yes? The 0.05 is saying, I want to know what 5% from 0 to, this kind of assumes 0 to 5% would be. Okay, so now let's actually do it, and you'll see what the number is, and I think you'll understand better when you see the number, what that means. Did you get 1,000 something? 1,000 what? 1917? Okay, I'm going to round. Okay, so I'll round to 1918. Please stop talking. Some of you are just chatting away. Stop it, stop it, stop it. Shh. Focus. Focus, guys. Thank you. All right. Can't have like 10 people talking in a little different conversations. All right. What is that number? That is obviously not the number of chickens in Botswana. It has to do with rhinos. What was it again? It was the, what was it about them? Their head size? What was this? The weight. Okay, that is the weight of a rhino. What does it have to do with anything? It's the lowest 5%. Do you get how those are the smaller rhinos? Your lowest 5% rhinos would be weighing 1,918. All right, last one. It's like this. I'll give you the problem from start to finish. We're going to keep the same numbers with the rhinos because it'll make it easier for you. I want to know if I want a rhino at the 95th percentile, how much would it weigh? A rhino who's at the 95th percentile. As in, he's a big one. What did you get for 95th percentile, sir? 2082. So that would be make him a really big 95th percentile rhino. You want a big percent on your ACT test, for example? Yes. All right. So you want to be in that, maybe you want to be in that 95th percentile or better. Okay. So let's talk ACT scores for a second. The average ACT score in the state of Minnesota is about a 25. Okay. Now, it's out of 36. In Minnesota, that's the average is about 25. Is our school's average 25? No, because you are above average. Not everybody is, but our average is above average. Our school's average might be more like a 28 than a 25. Okay? So let's say that our school's average, let's say go with like a 28. Let's say it has a standard deviation of 1. And here's my question. For our school, if this is true, what do you need to be in the top 10%? Another way to say that is 90th percentile. You should be using inverse. Inverse normal. Yes? Okay, I'm pausing for a second to help with the tech. Okay, so think for just a second. If I want this to be a high score, do you get that the typical score is going to be above 28 then? The answer for you, what you're getting right now, is top 10%, right? So it shouldn't be above 28? And what was it? 29.3 would put you in the upper what percent of our school? Top 10% of our school. Now, again, I am totally making these numbers up. Let's say, I do know that our average is somewhere around 28, okay? But let's say that our standard deviation is a lot bigger than that. Okay, let's say our standard deviation is 5. I want you to see how that changes things. Top 10%. Top 10%, which would mean 90th percentile. Do you get how that changed it a lot? All right, so what did you get? That's a little more like what the reality is. I know that our top 10% of our kids are scoring like 34s, 35s, 36s. Okay, so this is probably more realistic. What changed? What did I change? Standard deviation. So the standard deviation tells you a lot. All right. So that is the last piece of the puzzle. Now you should be able to answer these three questions. Okay, I'd like you to use CDF to answer question 2. And I don't have a inverse question, but we just practiced it like 5 seconds ago. Okay, so you should be able to find the z-score of this 3 right here. But wait, Mr. Server, you didn't tell me the average. You can figure it out. You didn't tell me the standard deviation. You can figure it out. Okay, and then I put 57% for this top number. I know that's totally wrong. Please do not shout out the right answer, but write down what percent on the normal curve are within 1 standard deviation either direction, and then what percent go out 2 standard deviations. There's 3 numbers you're supposed to memorize. This one, and that one. This one's almost 100%, but not. All right. Work with your partner to try to get the right answers to these 3 questions. Groups should be able to ace this puppy. Question?
What are the questions? Sorry,
Okay, did you seriously have headphones in and then just ask me that?
Well, I was gone.
Okay, I'm going to reiterate them because you were walked out to go to the bathroom. I understand. So number 1 was use your calculator to find the answers to these. I need the z-score of that 3 there. You'll need the standard deviation, which your calculator can tell you, and you'll need the average, which your calculator can tell you. On number 2, this is the 2,000 rhino herd. If the standard deviation is 50 pounds and the average one's 2,000, then what's the probability of finding a rhino that's less than 1,950 pounds? You grab one. What's the probability that it'll be less than 1950? All right, you should be able to answer all 3 of those questions. I'll pause for a second while you do. Okay. On number 1, how were you supposed to get the average? Well, you could do it the simple way. Add them all up, divide by 4. But the problem with that, listen. The problem with that is that you would end up not having the standard deviation. So I would just put them all into a list, L1, and then I would do one variable stats, it's called. All right, so how many of you guys actually did it that way? Awesome. Did you get an average of 2.5? Did you get a standard deviation of 0.5? All right, good. Now, just then in your head, you should be able to do this part. 3 minus the average, which was 2.5, all divided by the standard deviation, which was 0.5. And that is 0.5, and that is 0.5, and so it comes out to positive 1. What does positive 1 mean then? That they were exactly 1 standard deviation above, because it's positive, the average. Okay. So if I don't even tell you what your data is, and I know your data on the last test, and I said you were a 1.0 on the last test, would that be good? Yeah. That's true. It depends on what the average was. Okay. Let's say the average in here was an A-, but you were a 1.0. Do you get that means you were above average? Okay. And then it all depends then on the what? Standard deviation. Because if the standard deviation was like 10, well, and the average was a 92, well, then you would have to be at 102, which would be fantastic. Okay. So positive means above, negative means below. 1.0 would mean that you are exactly the standard deviation. Okay. So then, number 2, the rhino question. If you want rhinos that are less than 1950, you should have put in this CDF, and you want the minimum to be negative 999. Now, I know some of you probably put in 0, and it would probably work fine. But technically, the lowest number there is negative 99999, or actually, you could actually say times 10 to the, 99th or something like that to make it ridiculously small. Up to 1950. That was the lower limit and the upper limit. Then, of course, you always put in the average, 2,000, and then you put in standard deviation 50. Now, don't everybody all get up just because she has to leave early. All right, so focus. This, when it was all said and done, was a percentage. You, sir, what did you get? Can anybody verify about 16%? All right, good. So that means what? There's a 16% chance you are going to get a rhino that is that small. What does that tell you? That there's like an 84% chance you're going to get a rhino bigger than that. You know what I mean? You go 1 minus that if you want to get the other percent. Did you get that most of them around 2000? So it makes sense that you're going to mostly get rhinos bigger than 1950. Okay, and then the last one is I asked you to memorize this, and it's 68. And what's the next one? 95. And what's the last one? 99.7. I actually had to memorize those myself when I was taking a stats test to become nationally board certified. To be nationally board certified, you have to prove that you know your crap in every discipline, not like English, thank goodness. But in math, I had to prove I could do stats, I could do calculus, I could do pre-calculus, I had to prove that on these tests. And one of the things I was weak in was stats, because I'd only taken one stats class a long time ago. So anyway, that's one of the things I had to memorize. So it's worthy of you memorizing these 3 stats. 1 standard deviation out versus 2 standard deviations out versus 3. And do you get the point is that if you go 3 standard deviations out, you got almost everyone? You got 99.7. That's almost everyone is in that group. All right, so if we say shoe size, average in the United States is a 9. Let's say the standard deviation is 2. How far do you have to go out to get to that 3 standard deviations thing as far as people with huge shoes? So they start with a 9 and then you add how many standard deviations? 3 standard deviations that were each 2. 3 times 2 is 6. 9 and 6 makes 15. If you get to size 15 on the top end shoes, there's only going to be point something percent of people that have bigger than 15 shoes. Now, if you go to a group that is not random, like a professional basketball team, where they're really tall, then of course you're going to find a bunch of people that have like 15s, because that's not a random sample. Okay. Now, I get to the last minute or 2 here just talk about something called misleading statistics. And I did this already with a card trick, but I want to point out a couple of interesting ones. It's all about how you ask the question. Like, for example, let's say I asked you, have you decided that you're going to actually try in this class? Yeah. But do you get how the way I asked that question, he was kind of doomed? Like, it's sort of like, well, by him saying, yes, I've decided to actually try, that means that he sort of implies he wasn't before. You know what I mean? So it's all on how you ask the question. You can mislead people by asking a person a question in a leading way. Like, for instance, if you ask about the line item veto, just so you know what that means, the president gets this budget on his desk, and he can go, you know what, I'm agreeing with all of this, but I'm cutting this and this and this. Just don't like them. I can just wipe them out of the bill. Okay, if you ask the question to the American people, should he have the line item veto to eliminate waste? Then 97% of the people will say, yes, you should have a line item veto, because you kind of said it in a way that makes it sound like it's good. But if you just don't tell them what it is, you just say, should the president have the line item veto, yes or no? Only 57% will say yes. Do you get how it's just a slightly different way to ask the question, but it can totally mislead you with the results? Because you didn't know, like, if all you saw was this listed in a survey, you might not think about how they asked the question. Here's another one. When they ask about pollution and they ask, do you think traffic contributes more? Just by saying it first, people will tend to agree with you. Yeah, 45% say traffic is more responsible than industry. But if you say, do you think industry contributes more to air pollution than traffic? By just saying it first, people tend to agree with you. Look at that. 57% then agreed that industry was to blame. just by how you ask the question. Moral of the story, don't be misled. So your only homework for tonight is don't be misled. No new homework. Enjoy it. It's rare and precious like unicorns. That's all I have for you for today.